sounds good. I will turn me off.
Good morning, everyone. Welcome to the third and final day of the NCDOT annual meeting. This is the 10:30 to noon session. So I'm going to introduce our presenters, and we'll start the presentation. So first of all, I'd like to give a big shout out to Kittelson, as you see on your screen. They are our sponsor for this morning's session. Going to the first presentation, it's going to be a DDI guide, second edition, sneak peek. And probably introduce myself, Russell Dalton, Senior Transportation Engineer for the town of Apex. And fun fact, 10 years ago, I was ending my tenure as the NCDOT president, so it's been a whole decade. I've enjoyed the time off, and I'm really impressed with the way the meeting's gone virtually. It's a little different being in front of the computer versus being in front of a crowd, but it's amazing how far technology's come in the past decade. So first of all, Shannon Warchol, Senior Engineer with Kittelson, is going to give our presentation first to start off. She works with local, state, and federal clients to develop solutions involving safety and operations for intersections and interchanges with a special focus on alternative and innovative designs. Her recent work includes study of geometric and signal design for diverging diamond interchanges, investigation of the impact of flashing yellow arrow and leading pedestrian intervals on safety and operations of all users at an intersection, and implementation of automated traffic signal performance measures, ATS PMs in Virginia. Shannon is a member of TRB's Performance Effects of Geometric Design Committee and co-author of the forthcoming Guide for Pedestrian and Bicycle Safety at Alternative and Other Intersections and Interchanges. So with that, I'll introduce Shannon Warchol.
Thanks, Russell. And I wish I could be down with you all in North Carolina today instead of on a video. I would love nothing more than a good cheerwine float, some Atlantic Beach pie. But life in Pittsburgh is great too. So I'm glad I can be joining you all virtually. So I wanted to give you all a sneak peek to this DDI second edition, and this really came out of NCHRP 3113. Now this project has been running for 7 years now, so it's been quite the lengthy project. We had a number of partners on this team. It was led by ITRI, really had a heavy North Carolina focus, actually, led by ITRI. Wayne State, when Joe Hummer was there, was involved. Stacy Phillips with Kimberly Horn, Pinetop Engineering out in Utah helped us with a couple of DDIs there, and then Kittelson. I think we had, 90% of our team over the last 7 years has switched between these different firms, and with Joe going to the state, of course. So it's been quite an adventure to put this project together. Just to give you a bit of the timeline of where we've been with DDIs. So the first DDI, opened in 2009. And we released, or FHWA released, the first edition of the DDI guide in 2014. This project actually kicked off slightly before that was released. So before it was ever released, the first edition, we had already started working on the second edition with the RFP coming out in 2013. 3113A was really about the signal timing of DDIs. And as we started working on that, in 2016, we transitioned into 3113B, which was the study of the geometrics. So we've been continuing on through that. I think we were able to release the signal timing details in 2016, 2017, 2018, as those were coming online. So hopefully folks have been seeing those, but they will be incorporated into this second edition. 3113C then allowed the project team to travel across the country to 8 different states and provide training on the signal timing. And here we are now at the end of 2020. We are expecting this second edition guide to be released as report 959 sometime in the next few months. Not sure if it'll hit before the end of the year. It's going to be, it's an NCHRP project, but there's agreement with FHWA that it will likely be published for FHWA. So not sure exactly the final format it will be coming out as, but you will surely see it when it does. The second edition structure maintains a lot of the same structure as the first edition. We have the introduction and the policy planning, but then really chapters 3 through 6 were complete rewrites. So we have chapter 3 is the multimodal considerations. We have new safety data that's coming in. Obviously what was at the time brand new, now a few years old, signal timing and operational analysis details, and then this geometric design piece, which we finished writing over the summer. And then there were updates to chapters 7 and 8 as well. But really what we're going to talk about today are chapters 3 through 6, as those were where the major updates came in. So chapter 3, the multimodal considerations. While NCHRP 3113 was moving along, we also had NCHRP 725, which looked specifically at pedestrian and bicycle guidance in design of alternative intersections. And so that project was also Kittelson and ITRI. And so we were able to, along with additional partners, but because of that project team overlap, we were able to integrate the methodology from 725 into this updated DDI guide. So the chapter is, as I mentioned, a complete rewrite and really highlights this methodology. So Joe Hummer has been instrumental in kind of demoing this methodology across North Carolina, so you may have already seen it. I don't want to spend too much time on the methodology, but the concept is that there are, when you're conducting an alternatives analysis, instead of just considering the safety and operational impacts for vehicles, this methodology allows you to bring in pedestrians and bicycles and have a quantitative analysis in that alternatives analysis so that you can consider the impact to pedestrians and bicycles really in that quantitative way. And so there are 20 questions that you ask yourself about the pedestrian and bicycle movements. And you can see that 13 of those are related to bicycles, 13 are related to pedestrians, 17 are related to bicycles. And they cover things such as, do you have a long red time? We know that long red times lead to increased likelihood of risk-taking behavior among pedestrians and bicyclists. So, and we know at the alternative stage, you don't necessarily have your signal timing set there. So we've created guidance to help you think about, would we potentially have a long red time here? Also looking at things like, are there undefined crossings at the intersection, or how many lanes does a user need to cross? So in each of these questions, there are criteria that will give you either a yellow flag or a red flag. And then at the end of your assessment, you can score to see how many flags were raised through your assessment. And the hope is that you use this methodology in the alternatives assessment, but it can also be carried through all the way to final design to highlight areas that are in need of further consideration by the design team. So once you've selected your preferred alternative and started moving forward, where are those key areas to focus in on as you're working your design? As it relates to DDIs, in the second edition, we have key considerations. So of those 20 flags, we've highlighted the flags that are most likely to be applicable in the context of a DDI. And so you can see those listed here, both for bicyclists and pedestrians. And so what we've done then, in addition to highlighting those common pitfalls, is present 3 different design concepts. And these are the same concepts presented in report 948, which is the 725 report. So this top design here, we have our, it's a transition from on-street bicycle lanes. You can see this optional ramp off onto a shared use path that then has an inside crossing across the DDI. Our second option is an outside pedestrian walkway with bike lanes on the roadway, marked bike lanes. And then the third option goes back to an inside crossing, but instead of using the shared use path, this is exclusive facilities for bicyclists and pedestrians until you get into that median. And so in the guide, it talks specifically about, in each of these designs, what are the key considerations? We're very mindful of the fact that with this new 20 questions methodology, there's no intersection that's going to have a perfect score. So we're not, we don't have it in our mind that any intersection would raise 0 flags. And we think it's important to think about the local context of what's important to the local users. But for each of these designs, we do go through how they improve upon those key considerations and also what additional flags these designs might raise and some methods for mitigating those. So that's chapter 3, focus on peds and bikes, also discussion of transit, and that's a complete rewrite. Chapter 4 then moves into safety. So this was work that was largely focused on Tim Nye's thesis work, studying 26 different DDIs across the country, looking at their safety. This is a large improvement over the first DDI guide that was looking at 7 intersections, which were the first ones to come on. This set of 26, still, less than a quarter of the existing DDIs today. But at the time, those were the sites that were available for before and after crash analyses. Jim Bonison then went with the work that Tim had done and was able to create CMF functions. And so there's a large table in the report that allows you to kind of dial in on exactly what your DDI looks like. But the functions are based on the crossroad speed limit, the change in the crossroad through lanes. So that's from the before condition, if you're doing a retrofit, in the before condition, how many through lanes total in both directions did you have, and how many do you have now? And then the number of crossroad lanes dropped. So again, the total of both directions. Sometimes you'll have on the bridge lane drops as they turn left onto the freeway. This was found to be significant in the CMF function. So instead of in the table presenting it as a function, we presented it in the guidance. Instead of presenting it as a function, we presented it as a table because these are all discrete integers. And so hopefully that will make it more accessible to users. We also broke out the CMFs to consider total crashes, fatal and injury crashes, and then the PDOs. So diving into that function just a little bit more, we see that there's a greater reduction in the fatal and injury versus PDO. So that CMF is going to be lower for F&I crashes than it is for PDO, which is a good sign. In general, you're going to see a stronger CMF, so a lower CMF. When you have lower speeds, that's pretty obvious. When you have a higher change in the number of crossroad through lanes, and when you have fewer lane drops, so that the lane drops, those left turns on the bridge that are exclusive left turns onto the freeway, those tend to have some safety considerations, and the presence of those can result in some additional safety impacts. Now, you'll see when you see the table that there are a large number of these scenarios when you're considering the three factors do result in a reduced CMF, or a reduced crash. So you have a CMF under 1. There are some scenarios with the DDIs where we see that your crashes can actually increase. And so 26 DDIs is a great sample. But when you think about those three factors, the speeds, the change in the number of through lanes, and the number of lane drops, 26 DDIs don't necessarily capture the full range of all of those variables. And so I think there's still a lot of work that can be done to, as more of the DDIs mature, to do an additional analysis and refine that CMF function. But I think what it really highlights is, the DDI is not the silver bullet. It shouldn't be built everywhere. And there are some times where building it inappropriately could result in increased crashes. Chapter 5 then moves into operations. And so one of the things that I think is great about the work, and this was really all of these graphics were created by Allison Tanaka. One thing that I think is very helpful in the updated guidance is some standardization of movement numbering and phase numbering. So we're all very familiar with the NEMA phases, but how do those get translated into the DDI? And so we put forward, as you see here, some recommendations of a standard numbering scheme. And we think that having a standard, if not across the country, if state agencies or if local agencies that maintain a number of DDIs, if they can get on board with a consistent numbering, whether it's this numbering or another numbering, really that consistency can help with communication between consultants and the owner agency and the maintaining agency and their staff to make sure that everyone is on the same page with the signal timing. And it really does start at the movements. We put forward 5 different phasing schemes. And so when I talk about phasing schemes, I'm talking about large structures of how to create progression along the corridor. And so there are, and I'll get to them in a second, there are kind of these add-ons, but when we think about kind of the 5 main ways to move traffic without any of these additional add-ons, they really come in 3 categories. So there's 2 critical movement progressions, 3 critical movement progressions, and 4 critical movement progressions. And there's, as I mentioned, there's a whole 8-hour session of training on this timing alone, so I don't want to dive too deep into it. But we think that really here we have the two critical movement that shows the cross street progression. And I brought up this graphic just so you can see kind of what we're providing in the new guidance. You can see the movement numbering with the details of the phases and the overlaps. You see that time space diagram that shows you where you should be looking for that progression, what you're trying to achieve. And then down below, you see the expanded ring barrier diagram that has those great graphics, again, by Allison Tanaka, that hopefully help you visualize what is happening in sequence. And then we talk through the benefits and the challenges of each of these phasing schemes. So we have a progression scheme for the cross street. This then is the 2 critical movement progression scheme for the ramps. We also have the 3 critical movement phasing scheme and then for critical movement, option A and option B. So again, I don't want to dive too far into it, but if you crack open the guide when it comes out and you get lost here, our recommendation is generally start with a 3 critical movement scheme, and that will do you well the majority of the time. We've also added in here a table that talks through, depending on what your vehicle demands are, so whether you have a heavy left turn onto the freeway or off of the freeway, or maybe a combination of movements, we provide a recommendation of, you can see for each of the critical movement schemes, 2, 3, and 4, what your anticipated level of delay would be. So for critical movement, when you have a heavy right turn off of the freeway, maybe not the way to be going. And then you can see it, additionally, those numbering there relates to the movements that may be having some queuing issues. So it just helps you as you're creating your simulations, think about where you should be seeing concerns, even in these phasing schemes. And then, as I mentioned, we have these kind of add-ons or specialized signal timing applications. The manual or guidance talks about all of these, explains all of these. And then we also provide, again, another chart that says, given your volume scenario there across the top, how you would expect different strategies to perform, whether you would see a large decrease in delay, so that double negative in the green, or whether you would see a large increase in delay with that red double plus sign, may be a strategy to stay away from. So trying to give folks an idea of, when you first sit down, what are the strategies. This chart is intended to help you make that initial cut. I can't test every strategy. Which are the ones I should focus on? Let me think about what my heavy movements are, and maybe pick, the ones that look the most promising in a general simulation. Moving on then to the chapter on geometric design, another total rewrite. There were just 2 things that came out of this chapter that I wanted to focus on. And the first is really something that Brian Ray, for those who know him, has always held as a strong mentality, that a DDI is simply a diamond interchange form with some special geometric attributes, right? So sometimes DDIs can be a bit intimidating, but Brian has always maintained and tried to write the guidance in such a way that there's a few special geometric attributes, but really at its heart, the DDI is just a diamond interchange. And so don't throw out everything you know about geometric design when you start designing a DDI. Keep all of that great knowledge in your mind, but just focus in on these few key elements. And then the other piece too was that the DDI horizontal alignment follows fundamental design principles. So again, getting at, don't throw out those fundamental design principles that you follow in all of your other designs. Those are still key when designing your DDI horizontal alignment. So what are the pieces that we talk about? I wanted to highlight the piece about crossover angles versus tangents. In the first guide, there was some language about achieving certain crossover angles. We've softened that language in the second guide. We think there was a lot of focus on crossover angles, which is important. We do say that it's desirable to provide the largest possible crossing angle. But really what we think from our research over the last 7 years is that what's more important is to have 2 crossing tangent alignments. So you can see here in this image that through the crossover, we are on a tangent. And from our research of different designs across the country, we think having that tangent through the crossover and even a little bit upstream of the crossover is key to helping folks stay aligned as they're moving through the crossover and avoiding wrong way maneuvers. So back-to-back curves without a crossover through the tangent can just lead to a large number of problems. So the focus really is get the largest crossing angle possible, but if you have to sacrifice that to put in a tangent because of your right-of-way constraints, then make the sacrifice. The tangent is more important. And there were 3 real alignment fundamentals. So the guide talks about each of these specifically, but it's those horizontal curve radii, it's the tangent between the curves, so what we just talked about, and then it's tangents approaching and through the DDI. And those really carry into a few performance measures that I'll talk about in a few slides. But the guide dives into thinking about these three pieces as the fundamentals to get right in your DDI. In addition to describing those fundamentals, we've also put forward a framework for or an ordering for how we would recommend designs be completed, and that's designing from the inside out. So we know that oftentimes with the DDI, you change one tiny thing at the east crossover and it propagates all the way to the west crossover, and you get challenges. And so the method that the design guidance puts forward is to design from the inside out, starting with establishing the median width between the crossovers, and then going through to the ramp terminal intersections, followed by developing the ramp geometry, checking the crossroad, creating the crossroad alignment, and then completing those performance checks. So the performance checks then just a few of them are looking at the speed radius relationships. So for those who work on roundabout designs, this will be familiar that there's transition radii transition portion of the DDI that gets you into the crossover is intended to reduce those speeds. And so this performance check is just verifying that you have your smallest radii in the center of the DDI where you expect the lowest speeds, and then you have your high speeds probably on the crossroad, outside of the DDI, and in between those two, you have your transition speeds. We also think that it's important for folks as they're going through as a performance check to look at the terminal vista on approach. So if you see this top image here, the driver, as they're looking down the road, is well aligned to, they can see that there's an island in front of them, but it's a little bit difficult to see, right? So if you didn't have that island there, if there was no blockage of the terminal vista, you could just drive straight through without ever turning your wheel and end up on the wrong side of the road. So having that island there is great, but we recommend, and some states have done, putting in on the bottom image, you can see kind of these barriers. Utah calls them eyebrows for some reason. So adding eyebrows can help avoid vehicles looking down the wrong approach. Similarly, we think path alignment, and this really gets back to those tangents in the crossover, to avoid path overlap and to send your drivers down the correct approach as opposed to heading wrong way. That achieving path alignment is critical. So we talk about that. And then maximizing the vista through the crossover. So the longer that distance is from where they are at the stop bar heading into the DDI, the further they can see down the road, the more likely they are to be drawn towards that correct approach of the crossover. And it's hard to put this in guidance because of just the sequential nature of writing. But one piece that we found was key. I remember thinking back to 2014 when we all met to kind of kick this off, is the really strong need for a tie-in between operations and design. So pulling, I think sometimes we can run into the problem of we get, 65% into our designs or to whatever level, you're working on, and then all of a sudden you hand it over to operations and say, come up with a signal plan and place your poles, and then give it back to us, and we'll do our final wrap up. And for DDIs, that becomes a really challenging proposition. Where the signal poles are is critical in helping with sight distance and with creating those terminal vistas. Which critical movement phasing scheme you're using has implications on cues, obviously, which are very important in DDIs because of lane utilization, uneven lane utilization issues that we've known about for a number of years now is present in the HCM. So as much as possible, bringing the operations and the design teams together early on in the process. And this graphic here just presents kind of how those two pieces tie in together and steps of the process that should be happening sequentially. And so again, hard to convey that in a guidance document and still make things logically. We do separate the operations chapter from the design chapter, but as much as possible, those teams working in parallel will create a better final product. So I'll toss it back to Russell. Russell, I'm not sure if you want to take questions now or at the end.
Well, we've got 2 questions in the Q&A, so we could probably go ahead and take those now. And if there's any others, you can follow up. We can follow up at the end or take those as they go.
Sure.
But looks like the first one, looks like maybe Adam Fisher. What is the fastest design speed you've seen with the approach to a DDI and through the DDI crossover?
Yeah, so design speeds off the top of my head, I'm not sure. We did, as part of this work, go out and collect, as part of the first DDI guide, collect actual measured speeds, and the 85th percentile there, the fastest one I think I saw was 37 miles per hour across the bridge. So that's a long bridge. They're able to pick up speeds. One of the DDIs in Charlotte, we clocked a semi truck making a right turn off of the freeway at 55 miles per hour. So it really varies depending on which curves you're talking about. But most of the DDIs that we looked at, the actual performance speeds or field measured speeds were in the 23 to 27, I would say, that kind of mid-20s range.
Okay. And the second question, for the second edition, is there any discussion or analysis on using 1 controller versus 2 controller for operations?
Yeah, and I'm sure Jim, I know he's on this call, has lots of opinions on that. We do talk about 1 controller versus 2 controller. In the guidance, we presented all of the graphics as if they were 1 controller. Just for, you had to pick one to do the graphics in, but there is a discussion on that, and once that comes out, you can dive in, but feel free to reach out with specific questions.
Okay, and let's jump to the next presentation. But I see another question came in. If you want to answer that toward the end, or you want to answer that just directly through the Q&A.
Will do.
But let's see. So the next presentation that we have up is Innovative Turbine Interchange Work Zone Traffic Control. So the presenter for this one is Richard Odynski, a senior traffic engineer for WSP with 14 years of experience in roadway design and traffic control design. Richard has worked on several design build projects throughout NC over the past 7 years with WSP, including the recent R2828 NC 540 Triangle Expressway project. In addition to North Carolina, Richard has worked on traffic control design for projects throughout the Southeast, New York and Washington and Texas. When not working, Richard enjoys spending time with his wife, 2 kids, and 2 dogs. So Richard, I'll turn it over to you.
Thanks, Russell. All right, yeah, thanks again, Russell, for the introduction. Excited to present about this project. I think it definitely had some unique challenges, and I think we were able to plan and design some solutions that really gave a benefit to the project. And we'll just look at a handful of those today on the presentation. Okay, so just a quick project overview. Again, the project TIP number was R2828, and is the Triangle Expressway. It was actually administered through NCTA. I realized after sending in the presentation, I really didn't include them in the presentation, so I wanted to make sure I did mention that. It was a design build project with about a $400 million construction value. WSP was the design lead for the project, and we were teamed with the Lane Construction Company and Blythe Construction as a JV. The project was about 8.5 miles and went from just east of US 401 to the I-40 and US 70 interchange pictured here. The existing interchange was certainly the most complicated from a traffic phasing. Most of the project was new location with a handful of Y-line crossings, and certainly this existing interchange was the most complicated from a traffic phasing standpoint. Another thing I want to point out is there was an adjacent project or another project that we had to work around. The I-5111 project was a widening of I-40 and it came through our R2828 project limits. That project was actually awarded to ST Wooten. It was another design build project, and ST Wooten won the job several months before the R2828 project was awarded. So going into it, we knew there would be some coordination and some planning that we'd have to do to accommodate that project. Quick look at the original hearing map design and our team's proposal design that we got approved through the ATC process. The hearing map design was, I'll call it, I guess, more of a partial turbine. They had a lot more separated movements, individual ramps and loops, as you can see in the green on the left. They had a third level bridge structure for the NC 540 mainline traffic, actually went up and over the two existing US 70 flyovers. So that was a little bit more complicated from a bridge standpoint, but they were able to leave the existing US 70 flyovers in place. So their concept was a little bit more straightforward from an MOT standpoint. Our concept basically combined a lot of those separated movements into the turbine and added some capacity along the turbine ramps to make sure that it still operated as needed. And by doing that, we were actually able to eliminate the third level structure for NC 540 by incorporating those two existing US 70 flyovers into the turbine ramp movements. So how that compares from an MOT standpoint is the hearing map, although it maybe looks a little bit busier with, like I mentioned, a lot of the separate movements for ramps and loops. It was probably a lot more straightforward from a traffic control perspective because it was really just relocating the two I-40 westbound ramps that are at grade ramps, and then building some of the structures over I-40. So you would have had some additional complexity in the third level 540 bridge going over the flyovers, and maybe some complications with existing structural components or some traffic shifting to construct those. But overall, from shifting traffic and the actual work zone interactions with traffic, it probably was a little bit more straightforward. Again, our concept, because we got rid of the three levels, our proposed NC 540 mainline basically went through the two existing US 70 flyovers. So we were going to have to actually move those flyovers, which again, the original hearing map design was not going to have to do. So a little bit more complexity from a traffic staging and maybe schedule standpoint than the original hearing map design. But overall, a significant reduction in cost from bridge square footage and earthwork. So a few of the big challenges on the project I'm going to touch on today, like I mentioned, the I-5111 project. You can imagine just having separate projects and contracts in the same area and trying to build different things and have two contractors competing for workspace and traffic shifts certainly was going to require some coordination and some special planning to accommodate that. We also had a pretty significant amount of earthwork that needed to get across I-40. We'll look at that a little bit later. And then the last thing we'll touch on is just the overall kind of phasing to construct a turbine where you have existing interchange. So the I-5111 coordination was probably one of the biggest new challenges on something I've not really faced before, where you have, again, especially design build projects and contractors competing for the same workspace, different projects, different improvements, different patterns and schedules, but trying to do that in the same location. Certainly we knew there was going to be a heavy involvement going in, and our team and the 5111 team worked very closely with NCDOT and NCTA to make sure we were all on the same page as far as what the traffic shifts and schedules and construction staging sequence was going to be, so that way we could tie these projects in together. One thing you can see on the graphic there on the right is we actually had 7 different bridge crossings of I-40. Again, so that's essentially 7 different bridge crossings across the I-5111 work zone. So special attention was definitely needed to be paid there. So this graphic kind of shows two different aspects, right? The good part is traffic's pushed to the outside. You've got one set of devices with a temporary barrier protecting your work zone. So there's no conflict. Everyone's happy from a traffic standpoint. You've got a nice big work zone in the median. And that's kind of the best aspect you could get, right? Is it happened to work out. We're doing median work, both so you're protected and everyone's kind of happy. But the problem is now you have the I-5111 team is trying to construct median drainage and subgrade and paving operations and ultimately installing median barrier wall, while the R2828 team is trying to excavate for footings, and they have cranes set up for the 7 bridge piers that they need to build in the median. And so you end up with the conflict is actually in the construction operations and the staging in there, and not necessarily from a traffic pattern or the driving public. So that's kind of the bad side is this works out well from the traffic and the devices and kind of that aspect, but it certainly created problems with the construction operations and conflicts between the contractors. So what we were able to do is the I-5111 team, as I mentioned, was awarded their project several months before the R2028 award. So they had a pretty far head start on us as far as getting mobilized and beginning construction. So what we looked at it when we found their schedule is their first phase was actually to shift traffic to the existing median and place barrier that you see with the blue stars along the outside shoulder to do their first phase of construction, which was the outside widening. And so what we decided to do was try to accelerate our median pier construction so that way we had separate work zones and would not be in the way of the I-5111 team. And that way, when we were done with our median pier construction and they ultimately went to the next phase, that they would be able to do their median work and kind of go around our median piers already there in place. So what we needed to do, because the schedules wouldn't work out if we followed our kind of standard design scheduling, was our structure team actually advanced the substructure designs for all 7 of the bridges that are crossing I-40. They basically progressed the bridge design far enough to be able to get those substructure plans RFC'd and approved, which saved time from the detail work and the comments and approvals and submittals for doing the full bridge plan. So once we got those approved, we were able to set our own temporary barrier for the R2828 team, shown with the green stars, and actually go in and start construction of those median piers. So on the typical, you can see it's only about a 26-foot work zone in the median. So it was a lot more restricted than our team would have preferred to be in the median doing bridge construction. But overall, we definitely felt there was a benefit to get in there and maybe be a little bit cramped, but to basically be out of the way when the I-5111 team was ready to go in and start their median work. So overall, some really good coordination there, and I think it worked out well for both teams from a design standpoint. This is just a quick screenshot of some of the parts of our plans. You can kind of see the legend on the left and all the different patterns and hatching and things like that we tried to really distinguish what was being built and who was responsible for it. It's also a little hard to see, but we tried to show the I-5111 team's traffic patterns and devices in kind of more of a gray. And then anything that our 2828 team was responsible for was kind of shown in the bold and really called out in more detail. So that way it was a lot clearer that certain devices and traffic shifts were kind of the responsibility or done by a certain team, and what was going to be provided by the R2828 team to really clarify where traffic would be and what we would be installing in coordination with the I-5111 team. So earthwork across I-40, like I mentioned, that was definitely another challenge for the project. We had about 1 million cubic yards of borrow that needed to go from the east side of I-40 to the west side. Some of that was just from excavation in the existing interchange area, and some of it was actually from a borrow site to the east of the interchange. So we did look at a conveyor system during the pursuit, but again, with the I-5111 project there, we had some concerns about spanning over their work zone and any access we may need to go in to do any sort of maintenance if we had breakdowns or things needed to be adjusted as part of the system. So didn't feel that was the best option because of those coordination issues. So definitely needed to look at other options to try to not make those haul vehicles go kind of around the project, right? We had a pretty straightforward shot if we could just get across I-40. So what we were able to do is look at using some of the turbine bridges for hauling, and by kind of combining the US 70 movements onto one ramp and one bridge across I-40, it freed up a couple of the other structures to do hauling. And the bridge you can see that's adjacent to where traffic is with the red arrows, our structure design team actually increased the design rating or the design considerations for that to actually accommodate the large, what's typically off-road haul vehicles, the big earth movers that typically wouldn't go on highway facilities. So again, that provided a huge benefit with, relatively minimal cost to the project to get that efficiency in allowing them to go directly from the borrow site or the excavation on the east side to the west side of the turbine. So a lot of efficiency there. And like I said, certainly a minimal cost than a conveyor system. So the last thing I kind of want to touch on is just the overall phasing of the project and just how we did the traffic shifts to accommodate some of the conflicts we had with our turbine concept. The first phase is kind of what you would anticipate. I touched on the median pier construction that we tried to do early on to avoid the conflicts with the I-5111 team. But for the most part, other than that, it was really, kind of constructing the turbine ramps and beginning some of the work away from traffic. One of the things that's not shown on here, because the graphic is actually from our pursuit, and after award, we realized that the I-40 westbound to US 70 eastbound ramp was in conflict with a few of our bridges at the southern end of the turbine. And instead of having to wait for the final ramp to be constructed, because it did have some stream crossings and other things that were going to be a little bit longer schedule items, we actually basically rebuilt that existing ramp in a temporary configuration to get it away from the proposed turbine bridges. And that really sped up construction of those bridges. And once those bridges were complete, again, we were able to start that earthwork operation even before the US 70 ramps were ready to shift traffic. So that was kind of our biggest schedule driver for phase one, was trying to get those southern bridges done for the turbine to open up the earthwork operations. So phase two basically put the I-40 westbound ramps onto their final location, basically skirting around the outside of the turbine. So that freed up a lot of the interior area for the turbine, again, helped with earthwork operations. And the other big steps for phase two was the temporary pavement that we needed to build to take out the US 70 flyover movements and shift them to a temporary pattern. It was a pretty substantial amount of grading and earthwork and temp pavement just to make that shift. But it really provided a benefit by we basically only had to shift the traffic to a temporary pattern once. And for the amount of conflicts that we had with the new ramps and the bridges and the existing flyovers, we felt that was a pretty big benefit to only have to impact the traffic with one temporary shift. So you can kind of see as we go to phase three, traffic from the east coming from US 70 had a westbound median crossover to get barrier separated with eastbound traffic. They came across the same ramp where the red star is shown and across the bridge we looked at a little bit earlier with, again, barrier separated to provide that physical protection between the different directions. And then they transversed across what would have just been a fill spot with the temporary pavement between the two turbine ramps. And that basically got them to the outside of the turbine and ultimately allowed us to tie them back down to the existing ramps and basically keep the I-40 eastbound gores exactly as they were today. So those gores really didn't change at all for this initial phase traffic shift. And again, we felt that was a pretty big benefit to not impact I-40 as much as possible, again, for driver safety and for the coordination with I-5111. The minimal amount of times we would need to shift that traffic and impact their work zone, we felt was better. The last step we had for our phase three, we did have one conflict. You can see where the orange star is, where one of our turbine ramps crossed that existing loop. The RFP did allow for a weekend closure, and so our contractors were able to carve out enough of that gap to be able to construct that final tie-in over the weekend closure. So we did have a offsite detour of that loop traffic for a weekend to finish that small piece of overlap construction there. And basically at the end of that weekend closure, the traffic was shifted to essentially its final location on the turbine. It was still a temporary pattern because the NC 540 traffic is not open until the completion of this project, and there were two other adjacent projects as well. So it's really only the I-40 and US 70 existing ramp movements, but they were essentially placed in the final location here. And that basically just freed up the last ramp construction we had that was, again, in conflict with the existing loop, and finish up any of the other NC 540 mainline work in preparation for the other projects being completed as well. But basically the turbine will stay in this temporary pattern with just I-40 and US 70 until all of those projects are complete. And it's basically ready to go with its final pattern. So that's really all I have. It was a little shorter than some of the others, so I think we have time for questions if there's any. Thank you for your time.
Cool. I don't see any questions yet in the box, so I guess I'll start out. You know, one of the things you talked about was accelerating substructure design to get those piers in place to allow for the traffic phasing. When you talk about accelerating design, I guess what are some of the challenges with that when you're dealing with structure design, and what kind of savings are you talking about in terms of accelerating that type of work?
Yeah, so they obviously, again, had to do enough to be comfortable that the design wasn't going to change, because that wasn't going to help anybody if we had to go back and kind of restart. So the exact details, unfortunately, my structure design expertise, I don't know, but I know the detail work and the comments and the submittals and review time for, a lot of the detail work that goes into the deck and the things like that take time as well. So the savings was probably not, 6 months or anything like that, but it was certainly enough to get us a benefit where between the comment review and responses and design time bought us a few months. And like I said, because of the schedule for I-5111 already being ahead of us, really any time savings is what we needed, because what we didn't want to do is still be out there building those median piers and the I-5111 team be ready to shift and start that construction. So not sure what it ultimately saved us, but it certainly gave us a little bit of a benefit.
And then I guess I'll follow up. I don't see any other Q&A yet, but see, I was going to ask, like, is this the first turbine you've worked on for this type of work, or is this have you done turbines elsewhere?
Well, we actually at the same time as this one was going on, we were the lead firm for the I-3819B project in Statesville. Again, that was another turbine concept, and so it was kind of the first one, if you think about the fact that I was doing it at the same time as the other turbine. So it was actually a quite different aspects of what we had to get around. The 3819B project was a partial clover and kind of had one of the main ramp movements already built from the A project. So it was a little bit more straightforward. We didn't have quite the conflicts as far as the overlap and the conflict with ramps that we did on this one. So a little more complex on this one, but certainly still had some issues with trying to build big flyovers around an existing interchange.
Very nice. And I see some comments in the Q&A, just good explanation, and also very impressive, much better than the old original 5-legged dead chicken interchange concept. So we can thank Ed Johnson for that one.
All right.
Very cool. So if there are no other questions, we can move on to the next presentation. I can introduce the next one. Is there anything else you wanted to add at the end, or we got just a little bit of time left?
No, yeah, that's all I had.
Cool. Excellent. Thank you very much.
Thanks.
Okay. So let's see here. Get to the third presentation. First, second, third. So the third presentation, let's see here. We have 2 presenters here with bios, so I'm going to go through these, but the presentation is NCDOT traffic analysis process updates. So the first one, Mike Reese, after receiving his Bachelor of Science degree in Civil Engineering from NC State, he joined the NCDOT Traffic Engineering Branch, now Mobility and Safety Division, where he has worked for more than 20 years in the Congestion Management and Traffic Analysis section, the Signing section, the Traffic Control and Pavement Marking section, the Signals and Geometric section, and construction units. Mike is a registered PE and certified public manager in North Carolina. Mr. Reese has spent the last 17 years serving as a regional engineer, project engineer, and access review engineer in the NCDOT Congestion Management section, performing and validating comprehensive reviews of major transportation improvement program projects and traffic impact assessments for various development projects statewide. And the second presenter, as part of this presentation, Mr. Dunlop, James Dunlop. He's has a bachelor's degree in engineering from Duke University and is a registered professional engineer. He's been employed by the Transportation Mobility and Safety Division for NCDOT for over 30 years, first in the Signals and Geometric section, including 7 years as systems engineer, and the last 21 plus years as head of the Congestion Management section. Previously, he spent 4 years in the town of Carrboro as the town's transportation planner. And I've got, let's see, it's like a couple other bios here. I guess I'll ask Jim, is there somebody, I guess like that Tammy and Kimberly's bios, are they part of the presentation for this session?
Yes, they are.
Okay.
Kimberly and Tammy are our municipal and school transportation assistance group.
Okay,
They'll
so I
have
can give a brief
segment
description
here.
of those if you want.
If you would, please.
Cool.
Thank you.
Okay, Tammy Germiller graduated from State University of New York at Delhi with a degree in architecture. She worked for 14 years at New York State DOT in the structure design and traffic engineering groups until 2004, when she joined NCDOT, where she has worked in the traffic safety unit and MSTA group. And also Kimberly Hinton has worked with the Municipal and School Transportation Assistance, MSTA group, for the past 8 years. MSTA maintains the school traffic calculator, develops school studies, and reviews school traffic impact analysis. Other positions held with NCDOT has been in transportation planning and project development. So I'll turn it over to you.
Good morning, everyone. Everybody able to hear me okay? And we're popping the presentation up right now. Is the presentation coming up? Jim, you got it?
I can if you're not getting it.
Yeah, my computer, I want to chuck like a Frisbee this morning. I'm actually on my tablet, so.
That me or is that you?
So while Jim's pulling up the presentation, basically what we want to do this morning, myself and Jim and Kimberly, is to provide a few process updates regarding traffic analysis across different arenas, different perspectives. So next slide, please. So I'm going to begin with discussion of TIA submittal expectations. And I'll, one slide back, please. So I'll begin with TIA submittal expectations this morning, a little bit about what's up and coming and what some of our expectations are with regards to TIA submittals to the state. And then I'll turn it over to Kimberly Hinton, who will talk a little bit about expectations with regards to school studies and school TIAs. And then Jim will close us out this morning talking about more from a TIP perspective, different traffic analysis levels and some discussion. And he'll close us out with some discussion. Next, please. So to begin with, as anyone that submits TIAs in North Carolina is probably well aware, these are the three key documents, the three key pieces of information that are expected to be followed, required to be followed. We begin with the North Carolina general statutes, and then we have the driveway manual policy and the guidelines in order of importance for sure. And the issue we run into, as a lot of you are well aware, is we have the general statutes that were created at different times. Some of it dates back to the 80s or before. We have a TIA timeframe statute and a school statute that came out in 2017. Then we have the current driveway manual policy that was released in 2003. And since then, we've released some median crossover guidelines in 2004. We've had different incarnations of the NCDOT capacity analysis guidelines. The most recent modification was in 2015. So there's a lack of harmonization between these three key pieces of information. So that's what I want to take my time going over this morning, is really clarifying the expectations we have on TIAs and TIA submittals. Next, please. All of this is referenced on our website, I might add. So we have the driveway manual policy that was created in 2003. So now click, please. So we're going to have a revised manual that we expect to be released here in the next year or so. We're planning on releasing a rewrite of the driveway manual. And one of the key purposes is to try to harmonize a lot of this information. So I want to take my time this morning discussing TIAs to talk about 14 current expectations that we have currently, that we have had with the release of all these different pieces of information. And all 14 of these pieces of information will be addressed in the new driveway manual that, like I said, we expect to have released in the next year or so. So for the sake of time, I'm going to go over the highlights of some of these points, these 14 points this morning. But this presentation, there's a lot of detail on some of these slides, where each one of these slides discusses what's in the current driveway manual compared to what our expectation is, what will be addressed in the new driveway manual more specifically. So for the sake of time, I'm going to go over the highlights, but I invite each of you to go back through and look at this presentation on your own. I'm sure, like all other presentations, this will be posted on the NCDOT website after the conclusion of the annual meeting. So the first point I'd like to go over is mitigation. This is the one that we see that probably one of the most common issues we have with TIA submittal. So what's in the driveway manual is that the applicant is required to identify mitigation, not that they're necessarily expected to provide that mitigation, but they're required to identify that mitigation anytime we have different conditions exist, comparing existing conditions to full project build out conditions in the design year or the build year of that project. And those are related based on delay and level of service and queuing. And the clarification there, the expectation is that these mitigation improvements are expected in a TIA anytime any of these exacerbations are caused by the development, which a good way to tell that is when you're looking at future no build conditions compared to future build conditions. And then two other quick clarifications on that. Queuing, as is noted in the driveway manual in the last point, mitigation improvements shall be notified when the queue exceeds storage. In other words, there's a significant increase in queuing, especially on interchange ramps, significant spillback. We're looking at that. And it's final quick note is this is in the analysis guidelines, but then when we say queuing, we're talking about the 95th from an analysis or the maximum cube from a simulation, whichever is greater. 100 foot is our minimum for storage lengths, 25 foot increments. Again, those last 2 points are in the analysis guidelines currently. Next, please. So the next point I'd like to discuss is TIP project coordination. This is another big one that we've had a lot of questions on. And what the current driveway manual states is that coordination is required among key stakeholders anytime it's determined that a TIA or a development is on an active TIP project. But what we don't provide currently that will certainly be clarified in the driveway manual is what is that coordination? What does that entail? So it includes possibly a design year analysis of that TIP project, the applicant having to investigate what the status of the TIP is there a forecast, is there a preliminary design? And if there is a preliminary design, then the site plan has to be overlaid on that TIP plan. And one important note that me and Jim and Kimberly and a lot of us in congestion management make on an almost daily basis is at what point, what is the trigger for a TIP design year analysis? And that's determined based on the forecast. Was this particular development in the zoning or not? So those are all clarifications that will be further addressed. Next, please. So the next point is capacity analysis guidelines. I'm sure all of us, anyone that submits analysis for NCDOT is familiar with the capacity analysis guidelines that are referenced on our website. And they are expectations. We certainly expect all of the analysis guidelines to be followed. This is actually listed in the TIA submittal checklist. It says the applicant notes that all the analysis guidelines, the statutes, and the driveway policy procedures are adhered to, and there's a checkbox. And if it's not adhered to, then the applicant needs to provide any deviations and provide detail on any deviations. So what we expect is they are guidelines. They're not hard and fast rules, but they are standards. And any deviations from these guidelines require some explanation, justification, and the key stakeholders, especially the local stakeholders, the district office, us in congestion management, we need to all know about those deviations and concur with them. Otherwise, a TIA may be deemed not complete. So I'm not saying don't ever deviate from the guidelines. We're saying we've got to have that explanation, justification, and concurrence. Next, please. So local government regulation, this is another key point that we get asked on quite frequently. The driveway manual says if local requirements are more restrictive, then the local will govern. So the reciprocal of that is true as well, whichever is stricter. For instance, the 3,000 trips per day is the automatic trigger for a TIA on the state side. Most municipalities have less, maybe 1,000 trips per day. So in that case, certainly the local would govern. But if the local happens to be higher, then the 3,000 would govern. Next, please. So site plans with TIAs, there's a long list in the driveway manual. This comes up quite frequently, that there's a long list of items that, quote, must be included on the site plan. And there's a very robust list there. For the sake of time, I won't go through that list, but it's in the driveway manual, pages 14 and 15. But when a TIA comes in, that's going to be in advance of when that driveway permit application comes in. So a lot of times there's unknowns on that site plan. And what our expectation is, we need to at least see the proposed buildings, parcels identified on the site plan. It needs to be to scale. We need to see our driveway locations and types, adjacent existing intersections, especially public streets, and the internal network of the site plan. Those are the minimums that we expect to see, that we need to see on that site plan when submitted with a TIA. Next, please. Functional area. This is another key point that comes up quite frequently. There is a detailed figure that notes when a driveway or a median modification or median break should be avoided. There's a figure on page 27 of the driveway manual, but the clarification is how to interpret that data. And in the driveway manual, when we note storage, that is that 95th cube from analysis or max cube from the simulation, whichever is larger, then there's going to be a deceleration and taper on top of that, in accordance with the driveway manual. So that's one expectation and clarification. Next, please. Internal stem lengths. This comes up quite frequently. The driveway manual is very clear that it should be a minimum of 100 feet measured from the right-of-way line, but it's not crystal clear that it should be provided. Well, it certainly should be provided in the TIA. That is another expectation based on the 95th cube from analysis or maximum Q in those increments. So those should be provided, a minimum of 100 feet. Next, please. Traffic counts, that's another key point. There was a memo that Jim released on behalf of congestion management back in March when the lockdowns of the pandemic began, that we would allow use of older counts on a case-by-case basis. So what's changed since then? Well, not a whole lot, but in a case-by-case basis, especially in a certain area of the state where traffic has gotten much closer to normal, if schools are open and fully in session, then we may consider new traffic counts on a case-by-case basis. Next, please. The nomograph, which is noted as turn lane warrants in the back of the driveway manual, just a little clarification on how to use it, that you round up to the next 25-foot curve. An interpretation is if we're less than 50 feet, we're probably looking at direct taper. For between 50 and 100, round up to that minimum 100 feet, and then in 25-foot increments beyond that. And that it's a tool, it's not an absolute, but that it can be used. It's in the policy. I expect there's more than likely going to be an update or a replacement of this, but based on the current manual, it is an option, especially when analysis is not available. Next, please. Right in, right out. So there is a figure in the driveway manual that notes that a median barrier, which is really the most critical to prohibit lefts, to not allow lefts for a right in, right out intersection, even if we have a 2-lane road or maybe a 5-lane road. But a little clarification that a raised channelization island, more commonly referred to as a pork chop island, that should also be installed. Most often that's concrete, but doesn't have to be. It could be grass. Next, please. Fast food restaurants. So the driveway manual is clear with the understanding that there's a single menu board, that there's 8 vehicles from the menu board. We need to make sure that stopped traffic, that stopped queue at that fast food restaurant is not blocking our public road. So a little clarification, because the dual menu boards concepts has emerged in the last 17 years. So a little clarification on when the 8 applies based on the number of lanes and so forth. Next, please. So some other new information that's expected in the new driveway manual, certainly safety analysis, reviewing. We expect the applicant to review the Highway Safety Improvement Program map to identify any problem intersections. And they may need to do a crash analysis so that we can mutually, as all stakeholders, support a safe roadway system, not just for patrons to the individual developments, but along the public roadway as well, so that we can all be partners in that. And certainly we have the complete streets policy, the requirement to accommodate other non-vehicle modes of travel. That will certainly apply to future driveway permits and TIAs. Next, please. And then last, but certainly not least, is school TIAs and school studies. These are the statutes that gives us that authority. And there's a wealth of additional information on the MSTA website for additional information at this link below. So with that, I'll turn it over to Kimberly Hinton to elaborate more on school studies, school TIAs, and those expectations.
Thank you, Mike. Hi, everybody. So on your screen, you see the state of North Carolina. That's because Tammy and myself, we cover, the two of us cover the entire state, and we cover the divisions as noted on the slides. The upcoming slides is a lot of content, and I will not be going over every single slide, but it's more for your resource to look at your leisure. Next slide, please. So this is our definition and our purpose. We basically will help whoever, calls upon us as our partners. You see there's a list there, but whoever comes and reaches out to us to help them with a concern, will definitely help do that. And our purpose is strictly working with schools and to help to help the congestion around those educational facilities. Next slide, please. The overview for today will be the revised law that came out in 2017, and what are those required improvements that is in the law, a little bit about funding, and some update information on the calculator. Next slide, please. So this is the law that was revised. 136.18.29A has always been there, and it was expanded quite substantially. The General Statute 160A-307.1 applies specifically to municipalities in regards to school studies. And so the next couple of slides, I did put the law there. Next slide. Next slide. And next slide. Thank you. So the temporary rules is actually not proposed. I should have taken that proposed temporary rule out. This provides a lot more detail to the 136.18.29A general statute. And it was approved in February 23rd of 2018 to accompany that general statute. And it's on the next slide. Okay, next slide. So let's get into what the change was. What did that change accomplish? And it basically provided the Department of Transportation to have authority over all streets on the state highway system, as well as the municipal highway system. That's I guess the main emphasis of this law. Another thing it says is that in the bold at the bottom is that schools will be treated differently than other private and possibly other public developments because of this change. Okay, so what does that mean, being treated differently? Next slide, please. Basically it says that the school any required improvement for a school will be reimbursed by the department. Next slide, please. And this means the reimbursement will be any cost for any of the improvements that are required by the department. So if there are design fees or construction fees, even right-of-way costs and easements in regards to a public school, the department will reimburse for that. But it's those improvements that are defined by the department. Next slide, please. And here's a slide just saying the same thing for the municipal streets, that DOT basically will be the final determining factor for what's required. But here, the municipality will reimburse for those costs. So any improvements that are deemed required by the department, if it's on a municipal street, it will be reimbursed by the municipality. Now, of course, we're going to definitely be in partnership with the municipality. We're not going to just put something on the municipality, that it was not agreed upon. So we're going to basically look at the interests of the traveling public. Next slide, please. The next couple slides will talk about what we will not reimburse, and I'll let you read that at your leisure. If you go to the next slide and the next slide. So let's talk about the limitations and challenges. One of the ones I've already mentioned is that we'll definitely have to have some communication with the municipality in regards to what is deemed required. But the major thing here is that schools are not required to make the system whole regarding the capacity. And the department will accept some delay, some operational delay in regards to congestion around schools if it's for a short duration. So once again, schools will be treated differently from developments. Next slide, please. Another thing regarding limitations and challenges is the right-of-way. Public schools already can, by intimate domain, get the property that they need, but private schools and charter schools, which this law is under as well, they do not have intimate domain power, and neither will NCDOT on their behalf. So that's going to be a challenge when we're looking at school studies. However, even though it's a challenge, the private schools and charter schools should still make a good faith effort in trying to get the right of way that they need for required improvement. And the reimbursement would be at the fair market value. Okay, next slide, please. Now the TIA. So when a school hires a firm to perform a TIA, MSTA will definitely review it at the district's request, because the district has the authority on issuing the driveway permits. So with the authority on issuing driveway permits, they also have the authority on if a TIA is necessary for a school or any development, actually. Well, not all schools are going to need it, or not all expansions will need a TIA, but that goes back to that partnership, that project team where everyone needs to kind of look at things together and see and give our recommendations to the district on what's needed, but they have the authority and the final determination. So if it is deemed that a TIA is needed, then it must be scoped and approved by the district to receive any reimbursements. Next slide, please. Again, if a change for a school is small, or if nothing's necessarily will be required, the district may say it's not needed. And then we'll just kind of look and see what type of NCDOT required improvements are necessary. If it's small, but it still could possibly be a problematic intersection, then the district may say, let's just still not do a TIA, but just look at an intersection that's near the school. If you're uncertain, then a TIA probably should be completed, or at least the TIA needs screening checklist should be completed, so to get that conversation started. And the best time to get the conversation started in regards to TIA for schools is when your piece of paper is blank, when you're really just beginning to start that process. So, as the firms are talking to schools and getting that work, it's definitely best to advise the school to start way early. Okay, next slide, please. So who decides on what will be reimbursed? Because we have the TIA, and now TIAs are going to be considered, or now schools are considered, different than other developments. So who decides on what will be reimbursed? Well, I talked about a team effort, looking at that, and the TIA is a part of looking at what's going to be what needs to be reimbursed. So we consider a TIA to be advisory and not deterministic. We look at it as recommendations, and so then we look at what improvements are school traffic generated. So that the final approval will come from the state traffic engineer, or that's Kevin, or the state traffic management engineer, and that's Joe, with a signed memo or some form of documentation. Next slide, please. But that project team that I talked about is the district engineer with our division and regional traffic engineer, as well as congestion management and the MSTA group. So we definitely need a TIA when it's needed, and it will definitely help provide the recommendations to identify those required improvements. Okay, so let's move on to the MSTA calculator. Next slide. Yeah, and next slide. So right now, the calculator is currently being updated by ITRI. And so what we found within these last couple of years is that the public school tab, the estimates coming out of the calculator has been shallowing in the PM period and the Q length. So do you use a calculator now? Well, you know, what do you do? Well, the short answer is yes, possibly. You can still use it, but we still need to have that communication and conversation during the scoping process. This should be, like I said, determined at the scoping, but the local data is always best. MSTA has a number of TIAs in our database that we can kind of look at and see. Also, we have a number of traffic counts in our database that we can see what's been done around schools. And so the process is going to take a little longer if it's determined that local data is best to use for these upcoming schools and until the traffic calculator is updated. So next slide. Training. So MSTA has needed to do some training for some time, and so we're going to be developing some upcoming training, hopefully in the February to March timeframe. So if you're interested, please reach out to us, either Tammy or myself, or or Joe, and let us know if you'd like to participate. And if you have any questions or comments that you want to make sure that they're discussed in this training, let us know that as well. So thank you. And I will pass it over to Jim. You're muted, Jim.
I thought I had unmuted. I only took off the video. So here's the first of my 42 slides. Okay, just seeing if you're paying attention. This is my only slide today. Want to talk about the project development network, how it affects our traffic analysis. Many of you probably attended the IPD presentation by Derek Weaver and Brenda Moore yesterday. Just want to mention some updates that we'll be doing. Currently, our only tab in that large spreadsheet or timeline, depending on what you want, is tab 1 TM1, which is the first stage, and then traffic management 1, which is complete traffic analysis. We did not have time between these our stopping work due to our funding issues back in March, and when we restarted the process in August to get our tab in the right place, there will be in all likelihood a IPD or PDN 1.1 as opposed to waiting until the full second version is out. But basically, as you're doing traffic analysis, how we are going to streamline things is we're going to identify what's needed, and the identification of the project and the level of effort needed in that project will be done by the department and primarily by traffic staff, whether it's congestion management, whether it's division traffic. We will be working in conjunction on that. However, we've identified basically 4 stages, 4 levels of project involvement and complexity. Level 0 would be your bridge replacements with 700 vehicle a day bridges, those type of things where, or a bridge where it's away from any intersection, therefore there's no traffic analysis that's really needed. That's separate from the work zone detour routing, which may still be needed and some analysis may be needed on that. But for the most part, these are the projects where there is no traffic analysis needed. So there is no reason to do it. Level 1 would be your basic intersection operation. Can be reviewed by macroscopic analysis tools, whether that be Synchro, whether that be Sidra. That is level 1. That is very similar to our pre-qualification 26, which is interrupted flow. Level 2 is intermediate. That means we need to have more complex traffic operations that is best evaluated by microscopic analysis tools. That is our traffic simulation pre-qualification, which is 256. Then we are adding a third level, which is not in our pre-qualifications at this time, which is our advanced. Those are the top projects in the state. That's rebuilding, as an example, if it ever gets submitted and funded, rebuilding the I-77, I-85 interchange down in Charlotte, as an example. There's a few projects that are like that. Level 3 involves the highest complex traffic operations. We may be using dynamic traffic assignment. So we may have some projects that may not seem as complicated, but from a traffic standpoint, new alignment may be if we are assigning the traffic volumes to it. We're also working with traffic forecasting to see how we can streamline our two very closely related items. Soon, as soon as I can get done with some logistical issues that keep stopping me from getting this done, we will be redoing our pre-qualifications. We will have 3 TIP levels, the 1, 2, and 3, probably reusing our current codes. We will still maintain the TIA pre-qualification code 252, because if you are to be reimbursed for doing a school study, you must be pre-qualified in both TIAs, which is 256, and one of the 2 MSTA codes. MSTA is also going to be adding a level, and more detail about that will be coming when we send out all of the pre-qualification changes. We will be initiating that internally as opposed to using the online system as you do for routine renewals or new requests. So we will be implementing that ourselves. With that, that's the last slide. I did only have one slide, and I will stop sharing so I can actually see the chat and see what questions. Russell, I'll turn it back over to you for Q&A, and I think we left about 3 minutes.
Cool. Thanks, Jim. If anyone has any questions, please put those in the Q&A and we can read those out. So we do have a few more minutes, and as I wait for those, maybe I could prompt with a question. So one of the things I guess we've run into on the municipal level is what you mentioned about, or what Kimberly, I think, mentioned about private schools and charters. And we've also heard this with private developers. When DOT recommends certain improvements, they don't extend their powers of eminent domain to obtain those improvements. And I was just wondering, is there a law that prohibits DOT from doing that, or is that just operating policy based on internal guidance?
Well, that is the law. The private schools and charter schools do not have eminent domain power, so we as a department can't take that on their behalf because it's not a part of the law.
Okay.
If it is a public improvement outside the schools, we can, but our policy is we're not going to do it for the schools. Obviously,
Okay.
we have eminent domain capabilities. We're just not going to implement it for that. Just as, even though the driveway manual said that we would do that for developments if they could not get property to make some of their improvements, over the 17 years since that was written, we have found that was a problem, and we have decided not to use that power.
Mhm. Okay. And doesn't look like we have any questions yet.
They're still reading all of the details. And that was what it was intended to do, is put out a lot of information for you to read at your leisure. If you have trouble falling asleep, you can read some of the statutes. But we are all happy to answer questions. Three of us here, Tammy, Germiller can also answer the MSTA questions. And if you don't get a good answer from us, go to Joe or Kevin, who will then
Incoming
send it
president.
back to us.
That's true.
And
He is.
so we'd be happy to answer some questions and do some clarification. We'll point out that we will have a update to our analysis guidelines soon. We've got a draft in place. A lot of that will be for TIP work. We've sort of combined the two. We may try to separate them in a later edition.
Okay. Great. Thanks. So I see some participants are dropping out. Please, nobody else go anywhere. Leave me a few minutes for some really good announcements for this afternoon. I do want to thank our presenters, Shannon Warchol, Richard Odynski, Mike Reese, Jim Dunlop, Tammy Germiller, and Kimberly Hinton. Thank you for your work. I want to remind everybody the scholarship fund silent auction is online. Please go on there. Please bid early, bid often. Make sure to get your bids in. All the money goes toward the scholarships. It's very important that you do that as soon as you can. Also, this afternoon, the next thing coming up will be after lunch, which concludes at 1 o'clock. Starting at 1 will be the annual board business meeting. There'll be awards, scholarships, speeches, swearing into the new board, all the fun stuff we look forward to every year. Please attend that. It's a great event. I think the bingo thing may be going on at that too, from what I understand, so that we do every year. And again, just to conclude, thank you very much to our sponsor, Kittelson, and we'll be signing out. Thank you.
Thanks, everyone. Have a good lunch.